This is a short video to show the parts and operation of the Easy Fit low coolant alarm that's suitable for MGFs and MG TFs. A couple of exceptions being Mark 1Fs, because they have slightly different sized switch blanks, and TFs fitted with air conditioning because there are no spare blank plugs or blank switches in the panel. All of the electronics for this low coolant alarm are fitted inside a standard switch blank, as you can see here. This contains an LED, a buzzer and a microprocessor that does all the timing and monitoring. There are two parts to the kit: the switch blank, or the actual electronics which goes in place of the switch blank, and the wiring harness. The wiring harness connects the electronics to the coolant tank. The coolant tank will need to be obtained. This needs to be one of the later ones that is fitted with the coolant sensor. These are readily available from a number of suppliers. The coolant alarm is easily fitted, requiring no modifications to the vehicle's wiring harness. All connectors and plugs are pre-terminated. It can be easily removed from the vehicle and transferred to a different vehicle, and it doesn't require that the engine cover is removed to fit this. Fitting time should be approximately 1 hour. Replacing the tank is a fairly simple operation with almost no coolant loss, and as I say, should be accomplished within the hour. I'll now give a demonstration of the operation of this. As you can see, we've got one of the units connected up here via the wiring harness to the tank, and we have the ignition switch here. The first thing the unit will do when switched on is to go through a self-test. The self-test flashes the LED twice and sounds the buzzer once. This is to show that they are both working. Because this is such a safety critical feature, we need to make sure that it is actually working each time. It doesn't do it immediately. The ignition is turned on. It waits approximately 5 seconds. This is to allow the vehicle electrics to stabilize, and also if the vehicle doesn't start the first time and you need to release the ignition switch and then start it again, it saves multiple activations of the self-test mode. So if I turn the ignition switch on now, it was already on, so we'll now turn it on. We wait approximately 5 seconds. There's the LED, flashes twice, and the buzzer beeps once. The system is now armed and is waiting for or is continuously monitoring the float within the tank, and is waiting for the float to go low to give us an indication of this. If I depress the float, you will see that pushing the float down causes the LED to come on immediately. After approximately 5 seconds, it beeps once. 7.5 seconds, beeps twice, and at 10 seconds, it will be continuous. If I release the float, you'll notice that it doesn't stop beeping, or the LED doesn't stop immediately. And this is to prevent false triggers if you happen to go over a bump, and although you've got a low coolant within the tank, the float would bounce up and reset the system. We deliberately don't reset the LED or the buzzer immediately to give you an indication that there's been a problem. If I now release the clamp from the tank, you can see at this moment in time that the tank is filled to the maximum level. If I release the clamp here, this will simulate a leak within the cooling system, burst pipe, etc., etc. You'll notice that we are now down to the minimum level. In a few seconds we should see the LED come on. There's the LED. In 5 seconds it should beep once. 7.5 seconds, beep twice, and at 10 seconds it will be continuous. There we go. I will just turn this off. So that is the complete system. This is the tank that needs that is required to operate with this. As I say, they are readily available from a number of suppliers. This one is already fitted with the coolant sensor. They can be bought separately, or they can be bought as a combined unit. There's the part number for the tank. The coolant sensor, the actual sensor has a different part number. Thank you for watching. Oh, one thing to mention: the reason for the timings. We have the model, the 2005 model year cars were actually fitted with a similar system as standard. The system on those cars would wait approximately 45 seconds and before activating an LED on the dash. 45 seconds at 60 miles an hour equates to 3/4 of a mile. Personally, I wouldn't really be happy driving for 3/4 of a mile with low or no coolant in my system, and that's why the timings were chosen. The timings of 5 seconds for one beep, 2 at 7.5, and continuous at 10 over a long period of time has found to be been found to be very good without any false triggering. This is the Mark III version, the Easy Fit version. Mark 1 and 2 have been in use now for a couple of years, and there's been no false triggers on this system. Thank you for watching.